Now that we know what complex numbers are, let's see if we can do some arithmetic with them. Remember, a complex number is any number that we generally write in the form a plus or minus bi. It has a real part and it has an imaginary part. So the first thing we're going to take a look at, how do we add or subtract complex numbers? Well, let's take a look at just a quick example. So let's say I have 2 plus 3i plus 5 plus 6i. All right, now, the reason I'm using parentheses here, because technically these parentheses aren't doing anything mathematically, is so I can show you the two different numbers. Remember, all of this is one number, plus all of that is a second number. Now, the great news for most of the arithmetic for complex numbers is your intuition is going to be right most of the time. Now, like, I haven't told you how to do this yet, but if I were just to walk away right now and say, just figure it out, what you most likely would do would just be get rid of the grouping symbols and combine like terms. And that's exactly what you're going to do. We're treating the I just like it was any other variable, like it was an X or a Y or a Z. So if we combine kind of the real parts, we have a 2 and a 5, which gives me a 7. Plus, if we combine the imaginary parts, 3 and 6 give me 9. Those are I's. All right, in this case, remember, we always want to show our complex number in this form, the real plus or minus the imaginary part. Right, that's about as hard as it gets. If we have, let's do maybe one more. Let's say 2 plus I minus 3 minus 7i. All right, again, here we're either adding or subtracting complex numbers. First thing we want to do is get rid of the grouping symbols. Now, this second set of grouping symbols is doing something because this negative needs to be distributed. So this will be 2 plus I minus 3 plus 7i, right? We have to distribute that negative, or the negative 1 if you want to think about it as a negative 1. All right, again, we just want to combine like terms. So 2 minus 3 gives me negative 1. And let's see, I got an I and 7 I's, which gives me 8 I's. So there's our answer. It's in the right form. Here we have the real part plus or minus the imaginary part, or a plus bi. There's our answer. So adding and subtracting complex numbers is very, very straightforward. Like I said, the only way an author will ever make this more difficult is the numbers may be a little bit more challenging. It may be fractions or decimals, but it's still just basic arithmetic. Let's take a look at multiplying. Oh, come on, multiplying. So again, let's start out with just a quick example. 4 plus 5. All right, here we are multiplying two complex numbers together. One number is 2 plus 3i, the other one's 4 plus 5i. Again, your intuition would work very well here for most of you. If I just walked away and said, go ahead and multiply them out, you would do it just like we would do polynomials. Like if I had x plus 2 times x plus 3. You would take every term in the first polynomial here and distribute it into the second one. So you take the x and distribute it, and you take the 2 and distribute it. Well, guess what? Same exact thing's going to happen up here. So let's get rid of that. Okay, so let's see. If I take the 2 and distribute, that gives me 8 plus 10i. If I take the 3i and distribute it, that's going to be 12i plus 15i squared. All right, if this was a polynomial like what I just had right here, you would just combine like terms and you would be done. However, here's where it's just a little bit different. Remember, anytime we have an I to a power other than 1, we can simplify that. So I am going to combine some like terms. Here in the middle, I have 10 and 12 i's, so that's 22 i's. But from the past, I know I squared can be simplified to negative 1. So this is 8 plus 22i minus 15. Now notice I can now combine these two, so negative 15 and 8 is negative 7 plus 22i. Now notice when I did the arithmetic, I wrote the real number first and then the imaginary number. All right, so just like before, we're just distributing it out. The only difference with the complex numbers is when you end up with I to a power other than 1, you need to simplify that and then finish simplifying your number. So let me give you one to take a shot at here. Let's say if I said 3 plus 5i, 2 minus I. Okay, so here we're multiplying two complex numbers together. Do me a favor, hit pause in the video, scribble that down real quick and see what you end up with. All right, if you're done, let's see how you did. So the first thing I need to do is distribute the 3 into the second number, so that gives me 6 plus 3i. Then I distribute the 5i in the second number, that's 10i minus 5i squared. All right, as soon as we see I to a power, we need to simplify it. See, here in the middle, those are 13 i's. I know I squared is -1. So once I simplify that number, we get 6 plus 13i plus 5, so it'll be 11 plus 13i. All right, that's about as hard as it gets. Let's try one more here for multiplying. Going way back over here just for some more room. Let's take a look at a more generic number. We saw that any complex number can be written in this form, a plus bi. Let's do this. I'm going to say, what about if I did a minus bi? Now, remember from the past, y'all may not remember this word, if we have something that has two terms, two pieces, and the sign's different in the middle, those are called conjugates. Now, since these are complex numbers, these generally go by the name complex conjugates, but basically these are just conjugates. Now, remember, all conjugates mean is the same two terms with a different sign between them. Now, if we distribute this out, we get a pretty interesting result from it. Let's start by distributing the a to both pieces. So I get a squared minus abi. Then I distribute the bi, I get plus abi minus b squared I squared. All right, when I go to simplify this, a couple interesting things happen. There's my a squared. The two middle terms this time cancel. I get negative b squared. I know I squared is -1, so I get a squared plus b squared. Now notice what we ended up with here. This is a completely real number, right? All of our i's completely went away. So if you take a complex number and you multiply it by its conjugate, you always get a real number. We're going to use that fact here just in a second. Now, as a completely side note, something that's not in most textbook sections for this, we actually get a really interesting result by writing this the other way. So this is kind of a little piece of just side note, which means if I can write this, a squared plus b squared is a plus bi times a minus bi, right? I just wrote that backwards. This should look a little familiar to you because we know that this is true. A squared minus b squared is a plus b times a minus b. Notice this was our difference of squares formula for factoring. We did not have a sum of squares formula for factoring, but we kind of do now. So let's see how this would work if we actually wanted to apply it. If I wanted to factor something like x squared minus 9, that's the difference of squares, and I know that this would factor to x plus 3, x minus 3. Now, up until this very moment, if you were given this and if you were told to factor it, you'd say, I can't factor that. And even after this, a lot of times we'll say we can't factor it either, but we actually do know how to factor. It's the exact same thing, except for the second piece ends up with an I on it. So this will factor to x plus 3i, x minus 3i. So we can factor a sum of squares. However, even after this, a lot of textbooks will say that we can't because we had to use imaginary numbers to factor it. And a lot of times when we're factoring, we only want to use real numbers. But just kind of keep in the back of your head, you can actually factor a sum of squares. That can be useful in the future. All right, so we've learned how to add, subtract, and multiply complex numbers. So of course, the last thing we have to do is divide. There's both good news and bad news here. Let's go 2 plus 3i, 4 plus 5i. Okay, this is 2 plus 3i divided by 4 plus 5i, so we're dividing complex numbers. A little bit of good news, bad news here. We don't actually divide complex numbers. You know, like when we did long division in the past, something like this, we had an algorithm to help us do long division. We don't have anything like that for complex numbers. But here's the idea, and again, it's something we've already seen in the past. Just as a quick note, remember what I is. I is really the square root of -1. So what we actually have here is this. We actually have a radical in the denominator. Remember in the past, most of the time we're not allowed to leave a radical in the denominator, so we would rationalize an expression like this. And to rationalize, when we had two terms in the bottom, remember we multiplied the top and the bottom by the conjugate of the bottom. Now another way to think about that in today's terms, here we have an I in the denominator. Since it's a radical, we don't want an I in the denominator. So we need to get rid of all the i's in the bottom. What we just saw a second ago, if we take a number and multiply it by its conjugate, we get a completely real number, which means there won't be any more i's down there. So if I take this expression, what we're going to do is we're going to multiply the top and the bottom by the conjugate of the bottom. Okay, so I'm going to take this expression. I have 2 plus 3i, 4 plus 5i, and I'm going to multiply the top and the bottom by the conjugate of the denominator. Remember, the conjugate's the same two pieces with a different sign in the middle. So since this one's plus, this one over here has to be minus. All right, on the top, you do need to distribute all this out, so we got a lot of work to do on the top. The bottom, you can distribute that out as well, or you can just use our formula, right? We know if we take a complex number and multiply it by its conjugate, you get the real part squared plus the number in front of I squared. And that's actually what I'm going to do here. Now on the top, I'm going to distribute. So let's distribute everything out on the top. That gives me 8 minus 10i plus 12i minus 15i squared. So we did distribute all that out on the top. Now I said you can distribute out on the bottom if you'd like, but I'm going to use this formula. So in my formula, my A is 4 and my B is 5. So I know the bottom is going to be 4 squared plus 5 squared, just by using that formula. Oh, I missed a square here. I said it, I didn't write it. Okay, so let's simplify the top. We can combine some like terms. So we have 8 plus 2i, and I know I squared is negative 1. On the bottom, I'm just going to square these, and 25. So I have 8 plus 2i plus 15 all over 30, 41. Combining my like terms on the top, that's 23 plus 2i all over 41. All right, we're basically done now, right? Because we no longer have any i's in the denominator, so we're done dividing these two numbers. However, that's not quite in the form we're looking. Remember, all of our complex numbers need to be written in the form a plus bi. So the very last step you're going to need to do when you're doing division is go ahead and break this up into two pieces. So this will be 23 over 41 plus 2 over 41i. So the last step to make it fit the answer in the back of the book, always break your fraction up into two pieces. So let's try one more of these. Give you guys one to try, and that's going to finish us up for our arithmetic. So what if I had 6 plus I, 3 minus 2i? All right, do me a favor, hit pause on the video. See if you can divide, air quote, divide these two complex numbers. All right, you're back. Let's see how you did. We know that we don't actually divide complex numbers. What we do is technically rationalize the denominator. We're going to multiply the top and the bottom by the conjugate of the bottom. So it's the same two pieces with a different sign in the middle. So it's going to be 3 plus 2i. Now on the top, I need to distribute that out. So that's going to be 6. So it's 18 plus 12i plus 3i plus 2i squared. On the bottom, I'm going to use my shortcut. Now you can go ahead and distribute that out if you'd like, but I know it's going to be the real number squared plus the number in front of I squared. Simplifying on the top, that's 15 i's plus 2 times negative 1, all over 9 plus 4. So this is 18 plus 15i minus 2 all over 13. I'll bring it up over here for a little bit more room. Let's see, so it's going to be 16 plus 15i all over 13. Now again, that's completely simplified. It's just not in the form we want to leave our answer. We want it in the a plus bi form, so let's break this into two fractions. So that's 16/13 plus 15/13 I. And of course, if either one of those fractions will simplify them, simplify them. All right, that is arithmetic with complex numbers, so make sure that you practice this and you can add, subtract, multiply, and divide them.